So that was under assumption that firms decided quantities at the same time without observing what the other was doing. Now, instead assume that firm blue gets to decide first. So it decides, if we stick with the water example, how much water to put in bottles and to bring to the market. Okay. When that those bottles of water are on the market, red gets to make the decision, observing what blue has done. So blue puts red in for an established fact. This is what I've done now. How do you want to do it? It's up to you. So this potentially gives blue an advantage. We'll see that it does. It can increase its profits. So let's see how blue should decide. What quantity should it be setting? Well, we have the same, basically the same kind of setup that we had before. If we have 70 minus capital Q as the market demand, demand is given by 70 minus QB minus QR. So this is P of Q times QB minus the cost 10 QB. When we looked at Cournot, we said that each firm was treating the other firm's quantities as a constant in the maximization problem. Okay, and then we went back to solve the whole thing. What we do now, when we're in the case of blue, is that, well, this is not going to be constant. Okay, if we're blue, we're assuming that red is wanting to do as well as possible, given what blue decides. This is a B. Okay. What's that? Well, that's given by red's best response function. So we can plug this in. Instead of having this here, we plug this in. Okay. So let's do that. And the maximization problem for blue then becomes max QB, choosing that 70 minus QB. This is still the same, minus, and then we're plugging this in. So 30 minus QB over 2, like that, times QB minus 10 QB. Okay, as usual, we're going to be looking at the top of the hill where profits are the highest. We want to look at the first order condition for profit maximization. So we're differentiating profits from blue with respect to QB. So just 70 minus 2 QB. So here, minus 30, that's minus 30 QB, differentiating that. And then minus QB, or plus, right, because minus minus becomes plus. So QB squared over 2 divided by Q, or differentiated with respect to QB, becomes just plus QB. And then minus 10. And the first order condition, where is the slope of the profit function equal to 0, setting that. Okay, so what do we have here? We have 70 minus 30 minus 10. So that's 30. And then minus QB equals 0, or QB equals 0. Okay, so what do we have? Well, firm B, blue here, is going first. It's going to be producing more. It's going to be on red's best response function, and red is going in consequence. So what's red's quantity is going to be? Well, let's just plug in the QB. Oh, 0, that's not right. That's should be a 3 there. So 30. And for red, what's red's quantity? Well, that's QR equals to 30 minus QB, which is 30. 30 over 2 equals 15. Okay. So instead of each producing 20, the Stackelberg move being a first mover in the Cournot, or in the first, being a first mover in the quantity setting game, is associated with first mover advantage. So the first mover expands quantities relative to Cournot, and the second mover, the follower, shrinks relative to Cournot. Okay, implying higher profits for the leader, lower profits for the follower. Okay, so that's what's known as a Stackelberg model. And it's useful partly for thinking about the advantage of being first in these kind of models, and also partly because it really highlights what we're assuming when we're treating in Carnot, when we're treating the quantities of the other firms as a constant in the maximization. Okay.